Hi everyone, and welcome to our video titled Slope-Intercept Form and Standard Form of a Line. So we just got done finishing up slope and the slope formula, and now we're going to get into writing equations of lines in these two forms. So let's just start by reading through. This first page is just a lot of reading, so let's just go through it. Every line is unique and is made up of a connected series of points. Every line has a unique equation, okay? Every line has a unique equation that can be translated to a graph and a table. In the remainder of this unit, we will study three different forms or outfits for writing the equation of a line. These outfits are called slope-intercept form, standard form, and point-slope form. Today, we focus on the first two forms, slope-intercept and standard. So here is slope-intercept form. Slope-intercept form of a line looks like this: y equals mx plus b, where m is your slope and b is your y-intercept. And you might remember this from last year. You definitely have seen this before, but not so much on the next form. The next form, which is standard form, looks like this: ax plus by equals c. Two bullet points here. First, the number filled in for a must be a positive integer. So right here, the number that we put, oh, I'm dropping my pen. The number that we put for a, it has to be positive, and it has to be an integer. So we have to remember what our integers are. So like our integers from our former studies would be the whole numbers, both positive, negative, and zero. I really should say the whole numbers and their opposites. So like dot, 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 -3, -2, -1, 0, 1, 2, 3, dot, dot, dot. These are integers, but a has to be a positive integer. So a can only be these guys up here, 1, 2, 3, and so forth. So those are the types of numbers that a can be. Now the second bullet says the numbers filled in for b and c must also be integers. So we're still looking here, but they can be either positive or negative. So now you can run the whole gamut here. Okay, and we'll talk more about that when we do examples. And finally here I wrote, it is very easy to toggle between the two forms, like to go back and forth. Okay, so today we'll be going back and forth between slope-intercept form and standard form. They will represent the same equation, it will just be in a different outfit. Okay, great, let's flip the page. So next I said, let's begin with an equation written in slope-intercept form. So if you take a look at this equation, y equals 3x plus 2, that is in y equals mx plus b form. And so what we're going to do with that is we're going to fill in the table by finding the range for the given domain. So we're going to come in here for y. We're going to plug these values in for x. This is our domain. These will pop in here for x, and out will come the y's. Now, I think you're pretty good at this mental math, so I'm not going to write all this out. Can we do this in our head? So if I put 0, if I put that right there, 3 times 0 plus 2, wouldn't that just be 2? And if I put a 1 in for x, 3 times 1 plus 2, that would be 5. And if I put 2 in, 3 times 2 plus 2 would be 8. And finally, if I put 3 in, 3 times 3 plus 2 would be 11. So I'm finding the y values, this column, as x changes from 0 to 1 to 2 and to 3. Okay, so now we have some analysis. So it says, you can see that y is increasing by blank. So what's y increasing by? 2 to 5 to 8 to 11. What is the increase here? I hope you're thinking 3. As x increases by, what's x increasing by? I hope you're thinking 1. So the rate of change then, aka slope, rate of change means slope, the rate of change of the y with respect to x is we change 3 on the y for every 1 on the x. It's a 3-for-1 special. 3 on the y for every 1 on the x, which maybe 3 divided by 1, maybe you reduce that to 3. Now, there is no coincidence here, everybody. You know the format, y equals mx plus b, and we know m is slope. You see this 3? That is no coincidence. This is why this 3 matches up with this 3. Okay? Now, next. Oh, I kind of wrote that. You probably remember this as slope. And earlier in this unit, we developed the slope formula. You had that lesson already. I'm just reminding you here. Slope is how quickly y is changing with respect to how quickly x is changing, or the change in y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So I put here, last thing here, let's pick 2 points from our table to confirm the slope and the equation of the line we were originally given. So, like, say we weren't given this. Say this wasn't given to us. We just had this data. And from this data, they wanted us to construct the equation of the line. Well, we could pick 2 points off of this line. Any 2 points you like. Maybe I'll just pick these 2 right here. So I'll pick 1, 5, and 2, 8. So I'm going to bring those down here. So I'm going to pick 1, 5, and 2, 8. So we know how to find the slope when we're given 2 points. And that is to first label our coordinates. So this is an x, and this is a y, and this is an x, and this is a y. And this is my first set, and this is my second set of points. So when I take y sub 2, that's 8. Well, first off, you guys know I like to kind of set myself up here. I know I'm going to drop these 4 numbers into these slots. So I know that here I'm going to have my y sub 2, so that will be 8, minus my y sub 1, 5, all over x sub 2, which is 2, minus x sub 1, which is 1. And if you see here, that's going to be 8 minus 5, that's 3, divided by 2 minus 1 is 1. Okay, so this is confirming that the slope is 3. Now, how do you put the whole equation together? Well, we know that in slope-intercept form, y equals mx plus b, we are going to fill our slope in. So my first step is I'm just going to pop that 3 in for m, 3x plus b. But then I have to figure out what b is. So one way that I can figure out what b is to plug in an x and a y that go together, like right here, 1 and 5, that's an x and a y. I could pop those in here, which will then allow me to solve for b. So let me do that next. So I'm kind of out of room here, so let me just kind of come up here. So I'm going to let my y be 5. So I'm going to do 5 equals 3 times, now I'm going to put my x in. My x is 1 plus b. Solving this for b, I have 5 equals 3 plus b. Now there's 2 ways to think of this. Do we know what b is just by looking at it? 3 plus what equals 5? I hope you're thinking 3 plus 2 equals 5. Or you could, use that good old algebra. You could subtract that 3 from both sides, and you'll see that way also that b is 2. So this b right here is the number 2. So altogether, my final equation is y equals 3x plus 2. And that's what I was given up here. Y equals 3x plus 2. So it all comes full circle. You can have the equation, create a table from it, extract the slope from it, or you can just have points on the line and go backwards and create the equation of the line. This is slope-intercept form, and isn't it cool that we said earlier on the former sheet, remember how we said that in slope-intercept form, y equals mx plus b, m was the slope and b was the y-intercept? Well, check this out. This tells me that 2 is my y-intercept. In other words, this line is going to cross the y-axis at 2, right? Well, if you look at the table, check it out. This table says that this line does indeed contain the point 0, 2. And so, ta-da! This guy right here, this back end, this b, see, every time x is 0, anytime you fill in a 0 here for x, you're always going to be left with this back number b. So that's why this back number is always your y-intercept. And again, this, you've seen this, you probably did that last year if you were a student with CV. And so I'm just reminding you of some things you already know. Now here's the next part. It says, finally, let's transform our equation to standard form. This is the new thing, So check it out. So let me bring this down. Y equals 3x plus 2. So here's the thing about standard form. Let's remind ourselves. Whoa. Standard form has the x clear out in the front. So we've got to move some furniture around. You see this x term, 3x? We got to move him up and over to the front of the left side. There's a very easy way to do that. We just minus it. Minus 3x, minus 3x. So this is going to give me negative 3x plus y equals 2, because these will knock out. Now this looks pretty good, except we have some rules about the a, the b, and the c. And in this case, my b is just like a 1 here, 1y. But let's look back at our rule for a. The number filled in for a must be a positive integer. Right now, it's an integer, negative 3. I mean, that's on our list. Negative 3 is an integer, but it's not positive. So we have to do something to this equation to force it to be positive. So what I like to do, whenever I just want to make a quick sign change, I like to encase the entire equation in parentheses, and then I'll just go ahead and multiply the whole equation by negative 1. And when I distribute that negative 1 through, I will have negative times negative makes positive 3x. Negative times positive makes negative y. And negative times positive is negative 2. And so this is standard form. All three of these are integers, 3, negative 1, and negative 2. But this integer is positive. So this is my standard form. Okay, awesome. All right, last page of these notes has 3 examples, and what we're going to do is we are going to basically write all 3 equations in slope-intercept form and standard form. So again, it's like a 2-for-1 special. So let's start here with this graph, and let's write the equation of this line in slope-intercept form. So let's remind ourselves what slope-intercept form is. We are having y equals mx plus b. And then our standard form is ax plus by equals c. And I'll kind of draw a divider here. That might make it easier to organize it. Okay, so this is cool. When you're given a graph, I love when I'm given a graph because, man, I can just see what I need right here. I can count my slope and I can see the y-intercept. So let's count the rise and the run for the slope. You ready? From the point here on the left over to the point on the right, I'm going to count. I go up 1, 2, 3. So I'm coming up 3, positive 3. And I'm scooching to the right. Let's see how many. 1, 2, 3, 4. That makes my slope a change in a change in y, which is 3, and a change in x, which is 4. So I'm going to write y equals 3/4 x. Now I'm ready for my b. This is my y-intercept. So I look at the line. Where is it crossing the y-axis? Well, you can see it's crossing the y-axis down here at -5. So -5. And that equation is done. This is the slope-intercept outfit for that line. Okay, how do we move it to standard form? Well, the first thing we have to do is, well, I think the first thing we'll do is move this guy over. I know he's a fraction. We'll deal with that in a second. So let's do this. Let's bring y equals 3/4 x minus 5. Let's bring that over because we have, one thing I will tell you, in order to get to standard form, you're going to need your slope-intercept to start. Now, let's move the 3/4 x over. So let's minus it from both sides. So minus 3/4 x minus 3/4 x. Boom. That's going to give me, now careful of the order you write it in. I want the x in the front. So -3/4 x plus the y, positive y. So this plus this, right? Equals, these knock out. And I'm just left with -5. Now, this is a double whammy here in the front. Not only is the a negative, it's a fraction. But there's a cool, easy trick or way to knock this out with one shot. You ready? Put your parentheses around the whole equation. Now, we darn well know we're going to have to multiply by a negative because a negative times a negative will make that a positive. In addition to that, see this denominator here of 4? If we multiply out here by 4, we will knock that out when we multiply. So here we go. -4 times -3/4 is obviously positive. And then watch what happens. I'll bring it over to the side. -4 times -3/4. See, these will knock out. So you just have +3, so 3x. Another way, if you want to do it this way, you could put this 4/1. You know 4 times 3 is 12, and 12 divided by 4 is also 3. So that's another way to think of it, but I like the knockout. When you're multiplying, numerators cancel out denominators. Okay, now we take -4 times y, that's -4y. And finally, -4 times -5, that's +20. So there's your standard form. Very cool. Let's go to example 2. Example 2, write the equation of the line that passes through the points -1, -3, and 3, 5 in slope-intercept form and standard form. Okay, same idea. They want it in 2 outfits with the given information. No graph given, so we have to tackle this a little bit differently. Let's kind of start with slope-intercept, y equals mx plus b. Over here, standard, ax plus by equals c. Okay, here we go. In order to get to slope-intercept form from 2 given points on the line, we first start by marking our x's and y's, x and y. First set, second set. And from that information, we will get slope. So let's go ahead and do our slope formula. We set it up. Got to drop these numbers. There are 4 of them for 4 slots. So y sub 2 is 5 minus y sub 1, -3. Watch that double negative. Careful. X sub 2, 3. Here's another double negative, x sub 1, -1. So that is going to give me m equals 5 minus -3 is +8 because we turn that double negative to a plus. 3 minus -1 turns to a plus, so 3 plus 1 is 4. And so 8 divided by 4 is nice, it's 2. And so we've got ourselves a slope. Let me bring that over here. Y equals 2x plus b. Now, to find the y-intercept, we simply substitute one of these pairs in here for x and y. They got to come as a unit, though. You can't mix and match. It's this one or this one. I like to choose the 3, 5 because I don't have to deal with negatives. So here we go. The y in this set is a 5. So 5 equals 2 times the x is 3 plus b. So 5 equals 6 plus b. And some of you can just tell that b is going to be -1 because 6 plus -1 is 5, or you can subtract the 6, and you can also see there that b is -1. So final equation, slope-intercept form, y equals 2x, I'm taking that from up here, 2x, and now I have b minus 1. Ta-da! Now, click and drag that up here, bring it right on over, y equals 2x minus 1. Now, standard form, we want the x in the front. Simple. Let's move this x on over to the other side. Minus 2x, minus 2x. Careful of the order, put your x first, negative 2x plus the y, so negative 2x, positive y, boom, equals. Knock these out, -1. Look at your a, your b, and your c. They're all integers, but this one has to be positive. So do you remember what to do? You've got to multiply by a -1, just to switch the signs. So -1 times -2, that's positive 2x. -1 times y, negative y. -1 times -1 is positive 1. So your standard form, 2x minus y equals 1. Yay, now that one's done. And the last one, example 3, last one on the sheet. This is actually easier. This one's actually easier than example 2. So we'll finish strong here. It says, write the equation of the line with slope -4/5 that passes through the point 5, -1 in both slope-intercept and standard form. So they still want the two forms, y equals mx plus b and ax plus by equals c. And off we go. Now the cool thing is they already gave us m. We don't have to find it like we did up here. So that's nice. So let me pop that in. Y equals -4/5x plus b. Okay. Now we'll substitute the one and only point xy that they gave me. We'll sub that in so we can find b. So the y value is -1. The x value is 5 and plus b. Now what's awesome here, the 5's knock out. So -1 equals -4 plus b. And to solve for b, add that 4. So 3 equals b. Okay, so final answer for slope-intercept, y equals -4/5 x plus 3. So I have a y-intercept of 3 and a slope of -4/5. Now, click and drag that up here. Y equals -4/5x plus 3. I want standard form, so let's start by taking our x term on over to the other side. So we're going to add it to both sides. That leaves me with positive 4/5x plus the y equals 3. These are gone. Now, the cool thing is a is positive, but it's not an integer. Integer has to, no fractions for integers. So we have to knock this 5 out. So all you do is multiply by 5. When you multiply 5 times 4/5, like when you distribute here, those 5's knock out and you're just left with 4x. You could also think of it as 5 times 4 is 20. 20 divided by 5 is 4. Don't forget to keep going. 5 times y is 5y, and 5 times 3 is 15. So there you have it, standard form, 4x plus 5y equals 15. And just one final thought as we conclude here. You know, these are in different outfits, but they're the same line. You might think, really? Are they really? Well, yeah, because just check this out real quick. If I had given you this, right? Say I gave you, I'll just sort of turn this over here. Say I had given you 4x plus 5y equals, what is that? 4x plus 5y equals 15. And I said, hey, take that and move it back into slope-intercept form. In other words, like get your y by itself. Well, think about what you would do. If you wanted to transform standard form into slope-intercept form, we would start by minusing the 4x from both sides. So that would knock those out, leaving me with 5y equals negative 4x plus 15. And then to get y alone, I would just divide everybody by 5. And so then y would be negative 4/5 x plus 3. And that is slope-intercept form. So you can toggle very easily. You see me, here I have this, right? And I change it to that, but I can also take that and change it to this. That's why I said on that first sheet, it's very easy to toggle between the two. Same line, they're just in a different outfit. All right, great. Thanks for watching, everybody. See you next time.